Thank you so much for coming. So this is not as technical as what just Kevin, the other Kevin presented, right? So it's going to be very high level, talking about some ideas that we have implemented. I think there is huge debate about machine learning, as I'm sure all of you guys know. We're talking about real-time processing of data. We are talking about big data. We are talking about neurologic, how it's being applied, and deep learning and machine learning and all sorts of stuff, right? So we are not going to get into that. Basically, what we do is that we try to use machine learning, a very special version of machine learning, and deal with real-time data. So as you guys know, whether you're a person, you're an organization, or you're another machine, when you want to talk to another machine, okay, not in the sense that Google is trying to create a language, but talk meaning deliver some meaningful content from a device to another device or to another person or to an organization. What happened is that you either got to sit there 24/7 and watch it, right? Or you got to really have this little monkey, which we call it machine learning, sit somewhere, whether it's sitting on a client or a cloud or a combination, right? Talking to each other and deliver something meaningful. So I think that's really becoming more and more essential. Just to make it kind of more friendly type discussion or more obvious, I use the example. And the example that I like to use is making a qualified call from a vehicle to a 911 center. Okay, so that's in Europe they call it e-call. I'm a voting member, or used to be voting member of FCC on Next Generation 911. Okay, and we introduced the concept of IoT for public safety. We are not there. I mean, they call it PSAP, Public Safety Answering Points. These are the 911 centers. They never take a call from a machine. It has to come from a person. That's why we got ADT and we got OnStar and things like that, because they qualified that call and deliver it to a PSAP, a 911 PSAP. But that takes 3 minutes, 4 minutes, 5 minutes, and sometimes the heart could go away. In that, IoT really could turn that into a couple of seconds if you do it right. So if you go and read the literature, and I'm sure all of you guys are familiar, what's the main mission of IoT? Is to make machine talk and act on their own without getting people and human being involved. That's the ultimate goal. And again, when I talk about talking and acting, I'm not talking like start talking to you in French or English, whatever. Bringing something that's useful to you, whatever that machine's going to be. I give you a synopsis because I don't want to confuse. I think it's good always to start with something. So what we are trying to say is that if we use a near zero latency connectivity between the device and the cloud, assuming that everything's going to go through cloud at some point, and if we use a machine learning that could work in real time and filter the heck out of the huge amount of data that's coming, and use a hybrid cloud computing architecture, partially an edge type computing architecture, I think we can enable, well, we have proven it, that we can enable machines to deliver real useful information, not whole bunch of data to people. I'll give you a very good example. We're working with a very large Intel DoD system integrator. They have billions of sensors going around, right? I mean, huge amount of sensors going around. And they spend millions of dollars just to monitor these sensors. And what happens is that, you start putting thresholds, like, you want to look at the reckless driving. Your teenage daughter is driving a car and you want to make sure that she's not reckless, So you start putting these thresholds. I think Verizon is selling some of these, hum, right? You set up these are all static, and they all can provide very falsely data. Again, a good example is that she's driving 62 miles per hour in a very sunny, beautiful highway, and there is no danger, right? And you set the threshold to be 60 miles. Okay, false alarm's going to come. She's driving fast. She's reckless. Now, she's driving 40 miles per hour in a very rainy, very rough road and so on and so forth, that you got to really be around 15, 20 miles, and you don't get anything, right? So that's the kind of things that we're talking about. I mean, again, I'm just using that example. To me, if you look at it at the end of the day, what is it that IoT brings to us, right? What is, I mean, what's the, you know, I mean, in a business sense, in a commercial sense, in a real life sense, what is it that it's going to help us to make a smart decision faster? That's the bottom line. Whether we want to save money, time is important. Whether we want to save lives, you know, in case of public safety, in case of DOD, a soldier is out there, there is a pipeline, there is a water pipe coming to our house and something's being damaged. We want to shut it down quickly so it doesn't, you know, flood the water and stuff like that. All of that is really helping us to make a smart decision faster. That's the bottom line, and that's really through, you know, creating disruptive business models through IoT. So the reality is that we look at IoT, we actually call it Internet of Everything. If you count, and Internet of Everything to us is even coupons, deals, not just sensor data. And that's really the bottom line. That's how things are going to come. Anything that machines generate something, they are all going to become things. That these little things, whatever they are going to be actually, you know, that whole environment around us eventually going to come to a point that we need to look at it. Some of it is noisy, like, you know, many of these sensors, they inside the lab, they are perfectly fine. Again, I use the example of a connected vehicle and DOD type example. Everything in the lab works beautifully. You put it inside a car, you take it to a battlefield, you take it to some, you know, mission critical, whatever. All of a sudden, there is millions of noise coming. And that's just one part of it. The other side of it is that because it's coming 24/7, whether it's 15 minutes or every 1 second, doesn't matter. Because it's coming dynamically to us, a good portion of it is not wanted. Okay, I don't want to hear to this thing. I don't want to listen to it. I don't want to deal with it. So the bottom line is that you really want to process this, filter it, and get this extract this meaningful content in real time. That's the essential thing. And that's the difference between basically coming up with a hybrid, coming up with an architecture that can support the real time, not just the big data analytics, that has the power and they can process it and do these things. And the other thing is that, of course, delivering it to the right audience, whether it's another machine or another person at the right time and location. That combination is really the meaning of, you know, the content of our discussion. So we go back, like human being, if you look at human being, and as all of you guys know, the simplest definition of machine learning is that we mimic human brain. We use prior information because human brain learns from prior information. Somebody walks into the room, we look at him, and based on the prior information that we have gathered in the past 30, 40 years, we make a decision about that person, right? That's how machine learning is. Machine learning relies on prior data, prior information. So if you look at that, human being is also a multi-sensory device. We have eyes and ears and other things. And majority of things that we are going to deal with, again, I'll go back to the connected vehicle. You have airbag, you have GPS, you have accelerometer, you have a whole bunch of different sensors. So you are dealing with this multi-dimensional type stuff, okay, with different sensors generating or integrating into one device. We call it connected vehicle, we call it human being, we call it whatever, right? So this multi-dimensional, multi-sensory device, multi-dimensional data, highly statistically challenging, is coming to us at real time, and then we want to make decisions. So what are the key challenges that we have? Before we get there, if you look at it, and this is just for the sake of this discussion, but this generalization works almost everywhere. There are three really outputs out of any sensor. We either look at these sensors in real time. You know, there is a live streaming of this data is coming. Again, you know, you're looking at GPS data coming from a vehicle or airbag sensors or whatever coming from. You're looking at it real time, monitoring it real time. Or you look at all the stored data, archived data, and you do analytics on it, and you learn a lot. Okay, this connected vehicle is generating a lot of good maintenance report, and if you do this and you do that, you are going to save a lot as far as driving and cost. So these are the two key functions that we are quite familiar with. We want to introduce a third function, and that's qualified instant messages. And that's the one that uses the prior information that's coming out of the reports and analytics, so we can use all of that, bring it back as prior information, right? And then look at that live streaming of data, and rather than feeding it, which is humanly impossible to look at all the sensory information in our life. I mean, if Cisco is correct, 50 billion devices, connected devices by year 2020, right? I mean, everybody kind of agreeing or converging on that number. So if we normalize it, that's 20 to 50 sensors per person, right, per connected person. They cannot look at all of those sensors. So what we think is going to happen is that this kind of box becomes important. Qualified instant messages. We look at them real time. We use all the data and provide all sorts of good analytics and stuff like that through machine learning on big data analytics type machine learning. And then there are these qualified instant messages that really becomes fundamental to creating a meaningful conversation now. And let me give you a good example. If I can go and look at all the multi-sensory information that's coming from a vehicle, if I can go and look at what GM provided for different types of accident that has taken place in the past 20 years, if I go and gather all the Department of Transportation information about different accidents, how it happened, what kind of road conditions, what kind of weather conditions, all of that exists, right? If I can process all of that at the cloud and create these prior information, right, and start feeding it back, I think we can get close to something really interesting in a very high level. Again, I'm talking at a very high level. So machine learning, as I mentioned, mimics human brain, uses prior knowledge, and basically by educating itself, it has to make quick decisions. So if we go and get all of these information about different types of accident, now we have all these smart sensors within the vehicle, we can get to a point that based on a simple architecture, bringing it back, creating the prior information, feeding the machine learning, educating the machine learning, and part of it could come from the cloud, and part of it could come from the real experience of that vehicle itself, right? And now we come back and we introduce something called an adaptive and dynamic setting. So while you are inside the cloud and you have access to all these millions of information, you come back and you kind of move towards something like what Kevin was talking about, making some smart decision on the device itself, but at the same time that you're communicating back and forth with the cloud. So that adaptive kind of threshold setting, that adaptive dynamic setting of decision-making process and pushing it back to the device itself, now we are getting close to not just ability to make a qualified call to 911 from a device and bypassing OnStar and all these other things, but at the same time, that same model becomes a way for people and machine or machine to machine start talking to each other. And the criteria, as we kind of talked about it, let me go back. So the architecture basically has the prior information and knowledge that's basically feeding the machine learning through the cloud, passing the instant decision making, and having a portion of machine learning, as we call it, running at the client itself, an ability to be be awake and make quick decisions and so on and so forth. But more, or as importantly, creating a mechanism of a zero latency communication. Right now, when you go on WhatsApp, when you go on Skype, when you go people to people, is instant text messaging. And we don't have that for machine to machine or machine to people or people to machine type communication. And we need that. And that's the only way, I think, that you can combine the cloud and the, client computation and connectivity together and create an ability to go back and forth and basically bring this whole thing to the reality of what we want, that people start talking to machines, or machines now beginning to basically communicate with the cloud on an instant, almost, let's say, zero latency type stuff, communicate with the cloud, gather a lot of useful information, and have a limited computational ability at the client to make these smart and quick decisions. So that's where we propose a kind of hybrid computing architecture based on a very simple, dynamic, adaptive, basically threshold setting or adaptive dynamic decision-making process that takes place at the device itself. So, to make the story short, I mean, basically, we need to process, we need to filter, and geofencing becomes a very critical thing. Almost 30–40% of whatever we are dealing with has something to do with location and time. And if you look at the reality of us as a human being, we are either a space or time, and then we are quantifying or measuring something in a third dimension, right? So that's exactly how machines going to behave. And a good portion of devices, sensors, machines, processes, anything from coupons to an accident to a soldier walking into a battlefield to a little pipe that's about to blow up and spill oil into ocean or whatever, has something to do with location and time together. So that's important. And if we can do that and then use the machine learning to create these qualified instant messages, then basically this architecture becomes a valid architecture and a very simple and practical way of getting closer and closer to what we think is going to be an intelligent communication between machines and others. At the very, very high level, we talk about wearables, right? I mean, imagine wearables. What is it going to do for us? I think Samsung is working heavily on wearables and stuff like that. Majority of companies are working heavily on wearables and stuff like that. Wearables can make a normal person, healthy person, smarter, no question. Can take care of a lot of deficiencies that disabled people have, slowly help them to be much more mobile, and ability for them to make all these quick decisions through this connectivity between cloud and the devices that they are wearing. And then a soldier or a first responder that's in either some sort of mission critical type situation, be aware of what's happening in their basically area. They call it, so it's not just social awareness. That kind of mission critical awareness is very, very important as far as like how a firefighter, a soldier or whatever, they can behave and they can save their lives or save other lives and protect themselves in a critical environment. So all of that requires this simple criteria of it says my time is over. So this doesn't move. Anyway, I can't move it. Oh, sorry. Okay, good. So to make the story short, working through a near zero latency connectivity, which is very, very possible. The same way instant text messaging is possible. Using machine learning in real time, that's different from deep learning, that's different from a lot of algorithm based on neuroscience and so on and so forth. This special algorithm that you can work in real time. And then using a combination of cloud and the client computing so that there is a connectivity back and forth between them, passing different things going between the two devices. We think we can enable machines to deliver meaningful and pertinent content. And from that, I think the decision-making process becomes something that you can elevate it and start bringing machines to things like wearable and making people even smarter. I think the bottom line is that by going through that route, making a smart decision faster becomes highly feasible. So again, I kept that very general. Didn't try to get into a lot of details, but if you have any questions, please go ahead and ask.
How to make a near zero latency cloud connectivity?
The same.
Using, G5.
Well, you gotta accept one thing. You're either connected or you're not, right? Mm-hmm. I mean, I go and talk to a lot of people and I say, well, okay, what if this car is in an accident? I mean, I'm using a vehicle. Or what if this pipe blew out and it's not connected, something goes wrong with the connectivity? if you are not connected, there is nothing you can do, right? I mean, so the level, at the first thing is that you are connected. If you are connected, we have to also accept that whatever technology we are building, at some point it's going to intersect. We went from GPRS to 2.5 GPRS to 3G to 4G in a very, very quick time. And I think right now we have a technology that works over 3G, and it's near zero latency. I mean, it's very quick, very fast. So we have to accept the fact that the investment in infrastructure from AT&Ts and Verizons and these guys is going to take place, and this, the network latency is going to become smaller and smaller. We are working with one of the carriers that they are now, without going over internet, they are, not just for latency, but for also being end-to-end encrypted. They are bringing the pipe to our cloud without going over internet. So that already removes a lot of latency, right? So we are working with them, and we are proving it that it's very much doable, that we can go over their network, quickly get connected to our network, to our cloud, sorry, and then from our cloud, we are going to push the data without limited latency. I mean, when we are not talking about zero latency, we are talking about near zero latency. Go on.
So when it comes to building like machine learning driven IoT solutions, how much of it is repeatable from one business problem to another one? So you mentioned
not at all. I mean, you have a very good point. Exactly. Yeah. I mean, the data structures are different, right? So we have to go and massage and adapt to that data structure first. So, but there is a general algorithm that we have, for example, and then very good example. When we are talking about making a qualified call from a vehicle to a 911, completely different data structure than a soldier in a battlefield that has a whole bunch of different sensories and different noise problems and so on and so forth. So we have to use that, but it's going to take like 6 months if we have good, meaningful historical data. It's going to take almost 6 months for the machine learning to become really adopting to those kind of data structure. So each one of them is going to be different.
Even figuring out how to connect these things, right? Understanding the data structure is one thing. How to basically build something meaningful, some meaningful message out of, say, you are connecting 10 different data sources. How we can build something.
That part is easier, but I think dealing with the data structure is the most challenging piece. If I understand your question, I mean, I agree with you. Still, there is challenge involved. Yeah.
So, near zero latency could have quite a lot of definitions, right?
Yeah.
Kind of the easiest
Let's say
one to think
1
of
second type latency.
Well, the easiest one to think of is faster than what I can deal with. Right.
Okay, but
right.
look
So
at me and you are talking, right? And nature talks in binary, right? I mean, we can talk to any alien, civilization in binary type thing, 0 1s, right? Pretty much. You and I are talking in some sort of, you are telling me something, I make a decision coming back to you, right? So the bottom line is that the only way you and I are talking is because there is a near zero latency in what I learn from you or I understand from you and come back. And sometimes I don't understand and I need to quickly come back, right? So we are not talking about zero latency. Naturally, that's impossible. We are talking about dropping it from 30, 40, 50 seconds or a minute, which it is now, to sub-seconds.
But my point is, there may be some applications where a minute is fine, right? It is effectively
like
low
what?
latency. Right?
Like what?
Right? Well, that was actually my question.
Yeah.
Right? Is what application? How would you? Different applications have different latency requirements. Right? So, what are there applications now that can deal with the current level of latency, that we have within the system that exists? What's the maybe
Okay,
the
I
next
can give
one?
you a very specific and very general answer. Right? The specific is, okay, you are right. I'm sure there is something out there that you're happy with minutes of latency, right? But if in general, if you want to really bring this to get closer to this paradigm of intelligent communication between machines, then we have to remove latency. The same way you and I do not have any latency. You tell me something I don't understand, I come back to you, but I got to come back to you fast, right? I got to go back and forth, back and forth. That communication, we got to get closer and closer to near zero latency. That's essential.
I think again, it depends on the application, right? Because
Absolutely,
taking that
absolutely.
taking that latency
Yeah, that's
out
that's
of the,
true. That's
out of
correct.
it would be very costly.
I think even in the world of IoT, right, we are fast coming from where the latency used to be of the order of few minutes, forget about a minute. And it wasn't too long back when it used to be actually 10 to 15 minutes before you get any response back. And there is an application, if you were to ask predictive maintenance in a robot shop, for example, right, is 1 minute of latency going to kill you? Probably not, right? But
You
I
have
think-
time to respond.
well, you just need to make sure that you know when that sensor is reading red and you need to take some action.
Right.
But what he's talking about is, let's say someone needs to call 911.
I use that because that's a good extreme
That's a very
example. Yeah.
good extreme
But in
example.
general, I think when we get to this intelligent communication that we are, we are dreaming, and machine act and talk on their own, we have to remove the latency. We have to get close to near zero latency communication. That's the bottom line. It has gone. There is no way. I mean, I respect. It doesn't matter how much you spend time on building the most advanced processors. You still need prior information to make machine learning. And the majority of these information are sitting on a cloud. So there must be a communication between these two, back and forth. And the best way, again, yeah, there are cases that you don't need latency. The best way to do it is to remove the latency. Let them quickly go back and forth, back and forth. No, you're stupid. Your decisions are wrong. Let me do some processing here. You now use this. Oh, okay, now it's making sense, right? This has to go back and forth. And I think we have to converge toward, removing all these latencies. And that's why I think, again, I don't mention the name of the carrier. We've been telling them for almost a year and a half that you got to sit next to our cloud. I mean, and the clouds are, it's Amazon and AWS and Azure and IBM and so on. So you go, and now, a few months ago, they called us back and they said, well, guess what? You're right. We are going to create a pipe right to all these different, clouds.
Is this an MCOD thing? Or
Yeah. So I mean, this is moving toward that direction. And again, I'm sure we can find many use cases that you don't need, zero latency. I mean, it's not important. Okay. Any questions? Thank you so much. Thank you.